Lesson 3.3, Completing the Square. All right, to complete the square, we're going to take functions, quadratic functions, and turn them into perfect squares, which means we need to know what a perfect square is. So I have x plus 3 squared. That's a perfect square because it is something squared. But let's look at the pattern. So if it's x plus 3 squared, that is the same as saying x plus 3 times x plus 3. Multiply it together, x times x times 3, 3 times x, and 3 times 3, or 6x plus 9. Notice we could write this as x squared plus 2 times 3x plus 3 squared. So the 9 is half of the 6 squared. So in general, x plus k squared is x squared plus 2kx plus k squared. So if I compare that to the general form of a quadratic, ax squared plus bx plus c, the c is k squared. Well, k is 1/2 of b. So in a perfect square, the c should be 1/2 of b squared. You probably need to know that. So to complete the square, the c, the constant term, should be 1/2 of b squared. This problem asks us to complete the square and then factor. So this is kind of a practice. This isn't typically what we do, but it's a practice for actually completing the square. So our b is 8. So we're going to add half of the 8, so it'll be 8 over 2 squared. It's half of b squared. That's what we're adding to get the perfect square. 8 over 2 is 4, and 4 squared is 16. And then it says factor. All right, we can factor. To get x squared is x times x. To get 16 is 4 times 4. Outers are 4x, inners are 4x. That makes 4x and 4x is 8x. Hey, that's what we're looking for. Since they're the same, we would say it's x plus 4 squared. And notice, it's a perfect square because it is something squared. So let's try actually completing the square. So the steps to solve by completing the square. So we are solving by completing the square. Is you start by writing the quadratic, so the x terms are on one side and the constants on the other. So it looks like that. Next, if the leading coefficient is not 1, divide by everything by it. Well, my leading coefficient is 1, so I don't have to do that. But if, let's say it was 2, then I had to divide everything by 2. Next, we complete the square by adding half of b squared to both sides. Well, b is 6, so I'm going to add 6 over 2 squared to both sides. And of course, 6 over 2 is 3, and 3 squared is 9. 16 and 9 is 25. All right, I rewrite the left-hand side as a square, so I need to factor this. And it's always going to be, since we set it up this way, it'll be a perfect square. It'll be x plus 3 squared. Square root both sides. Don't forget the plus and minus. And then finish solving. So I'll subtract 3, so it'll be negative 3 plus and minus 5. Now if you can simplify these, do so. Negative 3 plus 5 is 2. Negative 3 minus 5 is negative 8. All right, let's solve this problem by completing the square. I'm going to start by getting rid of the 5, so we'll subtract 5 from both sides. And then we make sure it's 1x squared, which it is. So we don't have to worry about that. So next, let's complete the square. So I'm going to add half of the middle term squared to both sides, which would be 9 over 2, or 81. All right, then we factor. It's always going to be the x, that symbol, and that was 9 squared to make the 81. All right, square root. When you square root, don't forget the plus and minus. 76 is 4 times 19. So it'll be 2 squared of 19. And then add 9. So add 9, bit of 9 plus and minus 2 square root of 19. And we can't simplify that anymore, so we have two answers, 9 plus the square root of 19 and 9 minus the square root of 19. All right, let's solve this one. All right, let's start by subtracting the 12. Get it on the other side. This time we have a 2 in front of the x squared, so we have to divide everything by that 2. So I'll have x squared minus 11 halves x equals negative 6. To complete the square, I'm going to have to add half of 11 halves. Wait, what's half of a half is a quarter, so this will be 11 quarters squared to both sides. And again, that's half of, it's 1/2 of 11 halves squared. So that's 11 for 4 squared, or 121 over 16. All right, on the left-hand side here, let's factor it. It'll always be the x, that symbol, and then what was that? That was 11 over 4 squared. On the right side, I need to add fractions. To add fractions, I need a common denominator, so I'm going to multiply the top and bottom by 16. So I have negative 6 times 16. Plus 121, so that'll be 25 over 16. At this point, we can square root. Don't forget the plus and minus. And then finally add 11 over 4. So I'll have 11 over 4 plus and minus. Oh, the square root of 25 is 5. And the square root of 16 is 4. Hey, these are just regular fractions. I could simplify that. So if I add, I'll have 11 plus 15 is 16. Sorry, 11 plus 5 is 16. When I subtract, I'll have 11 minus 5, which is 6. Well, those could be simplified. 16 over 4 is 4. 6 over 4 reduces to 3/2. All right, another thing we can do with completing the square is to write a quadratic function in vertex form. So if we start with general form or standard form, we can complete the square to get vertex form, which is this, where h and k is the vertex. What we do is we start with standard form. Here's our example. And we group the terms with the x. So I'm going to put parentheses around the x terms so that they're grouped. To complete the square, remember it has to be 1x squared. So I'm going to factor out the number in front of the x squared. So it'll be 2 parenthesis x squared plus, if I'm factoring out a 2, it'll be 6x. I'm leaving a space, 16. All right, next we need to add the half of b squared to both sides. So I'm going to add half of 6 squared. I'm going to do that to both sides. However, on the right side, it is 2 times that. So on the left side, it needs to be 2 times that. So this 2 has to be there also. 6 over 2 is 3. Squared makes 9. Times 2 is 18. Six over 2 is 3. Squared is 9. Say, but you added 18 on the left, only 9 on the right. No, I added 2 times 9 on the right, which is 18. All right, next we're going to rewrite it as a perfect square. That's the parenthesis part. It'll always be x, that sign, and that number. So 3 squared is 9, so I have the 3. Finish by subtracting to get the y by itself. So it looks like it's y equals 2, x plus 3 squared minus 2. So now we're in vertex form. So we could read that the vertex is -3, -2. And you can also then say, since it opens up, a is positive, the minimum is -2 because the minimum or maximum occurs at the vertex.